Today's class is on what is a database. We have data available in several different formats that we know about already. We have data available in documents, we have data available in emails, we have data available in messages, we have data available in files and videos and so on. But we don't call that a database. We call it a database when we have data stored in an organized fashion. So let us try to understand what exactly is a database. So first of all, a database stores useful data. What do I mean by useful data? Well, it is data that is important to us in certain respects. We need to have a copy of that available. It can be data related to the business. For example, it can be data of a company's customers. What is the customer first name, what is the customer last name, what is the customer email address. All that is very useful information. And similarly, the company wants to have the data on its employees, so that is also useful data. So the database stores useful or important data for someone. The data within a database is organized according to the entities for whom the data is being stored. So for instance, we talked about the customer data. So the database can have a place within it where customer data can be stored, and there all the customers details can be stored, like their contact person name, their email address, their company name, their shipping address, their billing address, etc. Similarly, the same database may store details of employees. For the employee entity, the data stored may be the employee first name, the employee last name, their date of joining, their salary, their department, etc. So the data in a database is organized according to the different entities or different things whose data is being stored. When the data is stored in the database, it is possible to update the data, and this update can be done easily. By updating the data, I mean if new data is to be stored, that can be updated in the database. If existing data has to be changed, modified in some way, that can be done. If some data in the database has to be deleted, that can be done. So the data can be updated, like the customer, new customer is there, so the new customer's data can be stored in the database. If the customer's shipping address changes, then their existing shipping address can be changed to their new shipping address. If an employee leaves the organization, then their employee data can be removed from the database. So when the data is in the database, then all these updates are possible. Since the data stores is stored in the database in long-term storage, it is always possible to look at that data. For example, if customer data is stored in the database and you just want to find out the details of the customer before having a call with the customer, so the data is available and you can always look it up. The other benefit of storing the database, storing the data in the database is that it is possible to analyze the data in order to make decisions. For example, if the company wants to know which customer has ordered which product, and the customer information and the order information is available in the database, they can look at that information and they can use the information to make business decisions. The database has two parts. The first part is the data structure, and the second part is the data itself. The data structure means basically how the data is going to be organized in the database. For instance, if customer data is going to be stored in the database, then the data structure can be defined that yes, there is going to be data for the customer, and for the customer we are going to store their company name, their contact person name, contact person email address, their billing address, their shipping address. So all this information will be stored. So that becomes a data structure. Once the data structure is ready in the database, then data can be stored in that particular data structure. So we may have a lot of other information about the customer, but because the data structure allows for storing all this information, the contact name, company name, email address, shipping address, billing address, then from all the information available on the customer, this information can be stored. We'll see an example of what a data structure and data looks like in this video. But as of now, please understand that the data structure is what data is going to be stored in what format, and then the second part of the database is the actual data itself, the data values themselves. A database can be one of two types. It can be a general purpose database or it can be a specialized database. By general purpose database, I mean a database that can be used by several different systems. For example, if the customer information is available in the database, that database can be used by the CRM, the customer relationship management system. The same database can be used by the sales management system. The same database can be used by the management information system to generate some reports. So it is a general purpose database that is that can be used by several different systems for several different requirements. There are some databases which are specialized, which can be used for only a single purpose. One example of a specialized database is the email database. The email database contains the email addresses and email messages of the people working in an organization, and it is specialized because it is only useful for the email functionality, providing the email functionality. So that is a example of a specialized database. Mostly in this course we'll be focusing on general purpose databases that can be used by several different systems for their requirements. When we talk about database, we also talk about DBMS. DBMS stands for Database Management System, and it is a software that allows several different operations to be done on the database. The DBMS has operations or functionality that allow us to define the data structure. So if we want to define some structure for storing customer information, the DBMS allows us to do that. If we want to define employee information or salary information or department information, the DBMS allows us to do it. The DBMS also allows, it has the functionality for storing data into the database. So the first time storage of the data is provided for by the database management system. Then the DBMS allows to update the data, whether new data has to be inserted, existing data has to be modified, or some data has to be deleted. The DBMS allows all those operations. More importantly, the DBMS allows for retrieval or querying of data. So if some data is already there in the database, the DBMS allows us to look at that data and look at different data in the database according to our requirements. The main advantage of using a DBMS is that it provides all these operations to be done in a very simple manner. So which means that a user can put some command to the DBMS, and with that command they'll be able to add their own definition of data. They'll be able to store data with a separate command. With another command they'll be able to modify the data. With another command they'll be able to get the data, retrieve the data from the DBMS. Now the advantage of using the DBMS with respect to unstructured data is that the DBMS has couple of things. That first of all, the DBMS requires that we structure the data in some format. So there is first of all definition of the structure that is required, and then we can store the data and perform the operations on it. If your data is unstructured, let us say that you just have data lying in some random files scattered across your hard disk, then storing the data is not a problem. You can just put some data in some file, whichever you remember. But updating the data is problematic, because the same data may exist in multiple places, and you may update one place, but you may forget to update it in the other places. And getting the data, retrieval or query of the data is really problematic, because you may have multiple copies of data, or some copies of data may be incomplete, some copy of the data may be fresh, some may be obsolete. You're never sure which data you are picking up, so it becomes very problematic managing data in an that is in the unstructured format. And that is the main benefit of the DBMS. The DBMS allows us to define the structure of the data first, and then it provides us very simple ways to store the data, to update the data, and to query the data or retrieve the data. The DBMS has a couple of other benefits. First of all, it allows all these operations to be done manually. That is, we can give different commands for all these operations, and by one command we can store some data, by another command we can change the data, by another command we can get the data that we require. The DBMS also allows all these operations to be done programmatically or automatically. That means a software developer can write an application. That application will have statements, and the application can connect to the database, and using the DBMS it can automatically perform all these operations. It can define new structure, it can store data in the DBMS, the application can update data in the DBMS, and definitely the application can retrieve the data in the DBMS. So I hope this gives you an understanding of what is a database. A database is really an organized store of information, and it is controlled by a database management system. The data in the database is organized according to different things it represents. It is possible to do several operations on the data in the database. It is possible to define structure of the data. It is possible to store data. It is possible to update data, and it is possible to get the data. And all these things can be done by typing commands manually, or it can be done programmatically also by the application. So with that introduction, let us see an example of a database. So here is an example of a very simple database, and this database stores information about three different entities. First is that it is an internal database of a company. That means it stores the information that is of use only within the company, not to the public or not to the customers. So it stores information about the employees, it stores information about the salaries in the company, and it stores information about the departments in the company. So it stores information about three different entities: employees, salaries, and departments. Now, before any data can be stored, the structure of the data has to be defined in the database. So for the employee, the structure defined here is that for every employee we are going to store the employee ID, which is their unique identifier, employee's first name, employee's last name, their date of joining, their salary, whatever salary is applicable to that employee, and what department they are working in. So that is the structure of the employee entity. This information, in the case of a relational database, is called a table. It is in the form of table because it has columns. It has columns like this, and it has rows like this horizontally. So we can see several columns are there. Employee ID is one column, first name is another column, last name is another column, date of joining, etc. And for every individual employee, there is one row in this particular table. So let us see an example. So there is an employee called John. So their employee ID is 1. Their first name is John. Their last name is Devon. Their date of joining is 13th January 2013. Then their salary ID is 1, which we'll look into just a minute. And their department ID is 1. So this entire row contains data for a particular employee. And this row contains data only for that employee, no other employee. The data in one row is for a single employee. Why? Because the name of this table is employee. So that means it contains data about employees, and different rows are the different data for different employees. So the first row is data about John. The second row is data about Irene. The third row is data about Paul. The fourth row is data about Richard. Then similarly, we have the structure for the salary entity. So for salary, we decide that we are going to store the salary ID, sum ID. What is the base salary? What are the perks in the salary? And what is the bonus? Now, one important thing you will notice is that in the case of the employee John Devon, we saw that only the salary ID was given. Why only the ID was given? Because the data for the salary is stored elsewhere. It is stored in the salary table. So we can take the salary ID of 1, and when we look up the salary ID of 1, we find that the base is 30,000, perks are 20,000, bonus is 50,000. So which means that John Devon's salary is a total of 30,000, 20,000 and 50,000, a total of 100,000. Okay. Similarly, in the case of John Devon, we saw the department ID was 1, and department is really another entity because that is independent of the employees. So department has a structure. We decide that we are going to store department ID, name of the department, and who is the manager of that department. In the case of John Devon, we saw that the department ID is 1. So all the details about the department need not be given, just the ID is sufficient because department really is a separate entity. So when we look at department ID of 1, we find name is sales. So that means John Devon works in the sales department. And every department has a department manager, and the manager ID is given over here. So here the manager ID is 1, which means this one is the employee ID, because employee and department, they are related to one another. These two entities are related to one another. And we can see the manager ID is 1, which is the employee ID of 1. So John works in the department ID of 1. That means John works in the sales department, and he is also the manager of the sales department. So we can see that the power of the database, not only we can do not only can we structure the data, we can obviously store the data, we can update the data as required, we can query the data, but also we can combine the data and come up with interesting facts about the data by combining it in different formats such as not obviously visible. So that is the reason databases are very powerful and very heavily used by many different systems to store the data and to be able to do all the operations of data definition, storage, update, and data retrieval and querying very simply. So that is all for this video. See you in the next video.